This is problem 76 of Neetcode 150 and queens. So this famous problem, we are given a puzzle, uh, and the puzzle is basically going to be a chessboard, but it's not necessarily going to be by like a real chessboard. It's going to be n by n, and we are to return all the possible combinations. So like here in example one, you have two combinations, and what is the criteria to be an eligible um, an eligible board? Well, no queens can directly attack another queen. So if you've ever played chess once, you know that a queen can move to the right, to the left, up, down, as far as she wants to. She can also move diagonally. So you can see that this queen here can go there, can go there, can go there, can go there, can go up. This queen, same, right? Can go all the way to the left, all the way to the bottom, all the way to the top. But you can see that in this configuration, no queens can attack each other's. All right, so we also have to return something that looks just like this. Okay, so it looks quite quite complicated at first glance, but let's see actually how we can do that. So we know that, for example, for a board to be eligible, we know that we can only have one queen per row and one queen per column. So I think that this encode can be quite simple to add. So we can simply have a hash map, and whenever we add a queen to a certain row or a certain column, we just add in the hash map that the value of that row. So we will add 1. So we know that 1, the column 1 and the row 1 already have a queen in. So now on every call that we're doing, we want to check if basically the value or the column that we are looking at is already in the hash map. If it is in the hash map, it means that there's already a queen here. Okay, so I think diagonally and vertically, it's well, horizontally and vertically, it's quite easy to manage. But now, I mean, queens can go diagonally as well, right? So a queen can go there as well. So how do you define this? All right. So let's pause and take a look at this, okay? When I am at this position here, and I'll take another color than yellow because we can't see it. So let me rewrite this. So let's first draw this array. All right, now let's take color blue or violet. It's gonna be nice. So if I'm here with my queen, look at this, okay? What is the difference? What is the difference? Or no, I would say, what is the addition or the sum of the number of the row and number of the column, right? So we know that the row is 4, the column is 1. So it adds up to 5. And now here, well, again, our column is, or row is 3, or column is 2. So again, we have 5, right? Do I need to go all the way up to make you realize that on every single position on this diagonal, we are gonna have 5. So here as well, right? So in this case, we have the row 1 and the column 4, so we're gonna have 5. All right, so what we can do is that at the particular row and at the particular column, we're just gonna add both and see if both are, if that value that we have is actually in the, we're gonna create a set, actually a hash set for that. So we're in our set, we're gonna add the value 5. So now we can actually go again, do our calls, do our things, and whenever we want to see if we can add a queen in this place, we are gonna see if the addition of the row and the column equals 5, and is this value, well, is that value 5, for example, currently in the set? If it is, it means that there is a queen that can attack you in this diagonal. Okay, so we did one side. Now, what about this this arrow that points downwards to the right? Okay, well, let's try to figure out something, a pattern, okay? Um, if we add both the row and a column, on this first case we have 2. If we do the same for this case, we have 4, then we have 6, and we have 8. So okay, this doesn't work. Let's try to figure something else. Oh, okay, yeah. What if actually we subtract them? 1 minus 1, 0. 2 minus 0, 2 minus 2, 0. 3 minus 3, 0. 4 minus 3, 4 minus 4, sorry, also 0. Oh, great, okay. We have a pattern. Is that gonna work for all the other diagonals as well? Well, let's figure it out. If we have this, you have 2 minus 1, which is 1. Great. Now if you go this way, you have 3 minus 2, which is also 1. And here you have 4 minus 3, which is 1. Okay, so we figure out the trick. So now whenever we are at the position, we know the row, we know the columns, we just subtract them. And if that value is in the set of the, let's call these negative diagonals. Okay, so neg diag, because it's going downwards, and the other ones that are going upwards, call them positive diagonals. Okay, so we know that if the value that we have, it's not in the negative diagonals or the positive diagonals, well, it can be placed. And also if it is not in the column or the row that we are at. Okay, so let's try to implement this in code. Let's see how we can do that. So first of all, well, what do we know? We know that we want to have a set that will tell us if the value is inside a column. Okay, so we're gonna say call, and this column is gonna be equal to a set. All right, and actually in a row, we are gonna. Well, let me first tell you that we're gonna use backtracking. I think that most of you might have figured it out by this time, but we are gonna use backtracking, and whenever we add a queen inside a row, we're gonna use a backtrack on a backtrack call, and we're gonna go one row down. So we don't necessarily need to keep a set call row to know if we add a value in the row already, because on each call we're just gonna go one value down. So it won't be a problem at this place. So let's create our pause diagonal, which is also going to be equal to a set. We just want to store all the values. And oh, I wrote diod. Perfect. This is better. All right, and we're going to have our neg diag, which is also going to be a set. All right, cool. So what can we do after this? Well, we can create because we know that we have to render our result within brackets. So let's just call res, which is going to be an empty array. And we're going to add all our combinations within this res. Okay. Now we have to define a board. Okay. Because the thing is that how do we actually end up giving something that looks like this to the left, right? So we're gonna have like dot q dot dot, and then we're gonna have dot 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 q, and by the way, the dot is an empty space where there's no queen. So how do we actually do that? Well, let's create a board, okay? And a board is gonna be equal to a potential solution. And a board basically, it's n by n, right? So initially it's gonna be empty cases, and empty cases are represented by dot. And we want to have a dot times n. Okay, so if we have a board 5 by 5, we want to have basically these 5 dots, and we want to have also 5 rows. So we're gonna do exactly this. So give me 5 dots, basically for I in the range of n, and n is the value we're given here. So if they're giving us a value n of 5, they're telling us give me a board 5 by 5. So by doing this, we are going to have a row of 5 dots, and we're going to have 5 rows of 5 dots. All right, cool. So the setup is done. Now we can create our backtrack function. And actually, we don't need to know yet what we are going to give as the parameters in the backtrack. But we know that we're going to call backtrack here with whatever is in here, and we are going to return the result. So this is something we know we're going to do. Now, okay, let's figure it out. Okay, we know that we are first going to check if we're going to check if the value that we have, right, is it in a column that already has a queen, or is it in a positive diagonal that already has a queen, or a negative diagonal that already has a queen. So this is one trick we know we want to do. And then we know that we want to actually add a queen somewhere in the row and then backtrack on it on the row that is under this row. So what if we just actually pass the row inside the backtrack function and we start at the row 0. All right? All right, so okay, we can build upon this for sure. And we know that we're starting at the row 0. So let's go see to the left the example. We know that we have like this, right? This is one row. Then you have another row which is represented by 3 dots consecutively, and one queen. Then we have one queen and 3 dots. Right, so we know that row 1 is going to be index 0, row 2 is going to be index 1, row 3 is going to be index 2, row 4 is going to be index 3. So if we ever happen to have a row value, so if row is equal to the length of num, in that case here, it will be equal to 4. We know we are out of bounds, so we did the entire board. So if this is true, we are going to append to the result. So res.append. Okay. And we are going to return. Great. But what do we want to return? Because at this point, and I said I call this res, but I meant board, okay? So I apologize for this, and I will also create a res that is finally equal. Okay, so all right, once we, I just want to say quickly that I updated this part above because I I wrote basically the board inside the value results. Okay, so I just reset result to an empty array, and then I set the board to this n by n board. Okay, so all right, we know that so let's go back to this if statement. Okay, so if row is equal to the length of nums, it means that row is out of range. So we did the entire board. So we want to basically take our board, okay? But our board has multiple array within it. So, and we want to return every single row as a string. So what we are gonna do is that we are gonna create so we are gonna create like our instance of board. Let's call this copy, so we don't modify directly the board. We don't want to touch the board itself. We just want to take the instance of the board at this time or at this call, and we want to join them. So in Python, you do this, right? The quotation marks mean what do you want to add between the values in your string. You want to add nothing because we want everything to be next to one another. And then you say dot join, and this is going to create a string with whatever array is within the join. And the what you want to have in the join is well, it's basically each row for the row in board. Okay, hopefully that makes sense. And now we can append this to the results. Okay, so we're gonna append the copy to it. Great. Now the algo itself. Okay, so now we did pretty much the entire setup. We have to create the board now. So how do we do this? Okay. First of all, we're gonna go through every single position in each row, and we want to call a recursive call on this so we can see all the possible solutions that we have. Okay, so let's do for C in the range n, for C in range n. Okay, because what we have to do in each call, it's basically to navigate through all the columns within that row. Okay, and each call is going to go for a different row. So within this call, we have to care about the columns. So we're going to say for I in the range of n, and this is where we want to say, okay, is C, so is the column that we are at, is this in call, right? We call that call is a set that holds all the values where we know there is a queen in it. So is C in call, or hopefully you remember from the beginning of the video, R plus C in pause diagonal, diagonal, pause. All right. So if this is in pause diagonal, right, because we know that if we take our board, if we know that the positive diagonal is the purple, it's the purple array. So positive diagonal. Let me take the purple again. It's this. Whoop, excuse me. And we know that if we add both, if we add both, so for example, here we add the row 1 and we add the column 4, it's going to be 5. And here, if we add the row, like at this particular point, if we add the row which is 3 and its column which is 2, we're going to also have 5. So that's why we are checking here if R plus C is in pause diagonal, or remember the negative diagonal. So let me just erase that quickly. Right, no more purple. Okay, so now the negative diagonal like this, we know that the difference between the row and the column should be the same through this entire diagonal. So we're going to say OR, and now we're going to do R minus C, and this, if it is a good position, it should not be in neg diag, like this, okay? If it is the case, we're going to say continue. All right, so we're just going to pass this, all right? And now, okay, so what we're going to do is that for each column that are correct, we can place a queen in. We are going to place a queen in, and now we're going to call recursive call on the other row. Okay, so we're going to do that for every single column. So initially, we want to add 2 columns, the columns that we are at. So we're going to say call, then add C. And now we're going to do the same thing for the positive and the negative diagonal. So initially on positive diagonal, we're going to say that we want to add R plus C. And on the negative diagonal, what we want to add is R minus C. Okay, and then on the board, at that row and at that column, we are going to add the queen. So how do we add a queen? Well, we are just going to say that this is, instead of a dot, which is an empty space, we're going to add a Q. All right, and now we're going to call our backtrack, and we want to backtrack on R plus 1, which is then the row under it. All right, so now we're going to go do all the possible solutions by adding a queen on this place. But recall that this is a for function, so we can actually try to add a queen on every single position or every single columns in that row. So what we're going to do is that once we call this backtrack, we are going to remove everything. So we're going to say call that remove, and we want to remove C, and now we're going to say pause diag dot remove, and we want to remove R plus C, and now we have neg diag, and you want to remove R minus C. All right, so now we undo what we just did by adding a queen. The last thing is to set the board at this row and this column equal to a dot, so an empty space, right? So now we're gonna go for the second column, and we are gonna try to add a queen in this second column, and then backtrack, see if there's a possibilities with this setup. So that's the algo. So let's try this out. We got an error. So the name nums is not defined. Yeah, right. So we're using n. not num. So pardon me for this. Hopefully that was the only error. As I said, get this wrong again. So int has no length. So let's debug that. Uh, yeah, so we're already using it